Good morning, students. Those who are preparing for JEE Mains and Advanced. Today, I am going to discuss about the how can you find the time period of the spring, block, and pulley system. I will explain both general method and shortcut method also. Let me start with general method. See, a block of mass m connected to the pulley along with the spring of spring constant K. Okay. Now how can you find the time period? Suppose whenever the block is slightly displaced downwards and block performs simple harmonic motion. Isn't it correct? Now let me analyze the tension. Suppose T is the tension in the string. See, this is rigidly inextensible string. Now this is also tension T. Okay, what is the tension now? 2T. Correct? Now what is X? X is the displacement of the block. Now this is inextensible string. What is its displacement? 0. But this is spring. So what is this displacement of the spring? X1. Understand, students? X is the displacement of the block. X1 is the displacement of the spring. But what is the displacement of this wire or string? 0. Correct? Because inextensible string. You learned in Newton's laws of motion. The displacement of the pulley is average of average of displacements of the wires which are connected on both sides. Again I will repeat, the displacement of the pulley is average of displacements of the wires which are connected on the both sides. Yes or no? Correct? But displacement of the pulley is same as displacement of the block is equals to average of acceleration of the wire, means this is spring. What is the acceleration of displacement of the spring is x1. What is the displacement of this wire? 0. So by 2. Understand? I hope you understand. Are you clear, students? Understand? Therefore x is equals to x1 plus 0 by 2. So what is x1 is equals to 2x. What is x1? Displacement of the spring. Students, look at the diagram. What is the restoring force provided for this block? 2T. Therefore, Fr I am representing. Restoring force is nothing but 2T. Correct? Restoring force is nothing but 2T. Now, let me write T value. But see, look at this diagram. T is nothing but Kx1. Correct? So, T is equals to K into x1 means 2x. Therefore, what is the value of restoring force now? 2 into K into 2x. Isn't it? So, what is the restoring force we got now, students? 4kx. Understand? Clear? Therefore, I am writing minus. Negative sign here. Why should I keep negative sign? See, restoring force and displacement of the block both are in opposite direction. Here, block performs SHM. So, you have to write the restoring force for the block. So, let me compare with Fr is equals to, minus spring constant Ke into x. K is the effective spring constant. Instead of Ke, what we have? 4K. Students, yes or no? So K is equals to how much? 4K. Therefore, K is equals to 4K. Isn't it? So what is the time period now? You know the formula. Time period T is equals to 2 pi into root of m by K. What is K now? 4K. Are you clear, students? Understand? This is the general approach method. Okay. Now let me analyze about shortcut method. Shortcut method. Identify the number of springs in the given system and check whether springs are connected in series or parallel. Then for each spring constant is K into tension in the block by tension in the spring whole square. This is the shortcut method. Directly you can calculate. See, students, for this example, K into what is the tension in the block? 2T. What is the tension in the spring? T whole square. So what we got now? 4K. Therefore again, what is time period? 2 pi into root of m by 4K. Understand? 2 pi into root of m by K. So students, this is in this system we have only one spring. Suppose if we consider system as 2 springs or 3 springs or 4 springs, how can you calculate the time period by using shortcut method? I will explain in next video. Thank you.